Good afternoon, everyone. I would like to welcome you all for the second day FDP on the Gen-based hybrid deep learning approach for IoT, organized by the Department of Computer Science Engineering, Vinayaka Mission, Kripananda Warrior Engineering College in association with Pencil Bits. I take this opportunity to welcome our today's speaker, Dr. Madhumita ma'am is serving as a K assistant professor in the SRM University, Katankolathur, where she's combined her academic expenses with the passions to innovation teaching. Specialized in deep learning, and she's committed to the empowerment students with the knowledge and skill required to the excellence in career. Her dynamic teaching approach increases the real-world applications with theoretical framework and creating the stimulating learning and environment through inspiring critical thinking and the problem solving among her students. In addition, her teaching responsibility, Dr. Madhumita ma'am, is actively engaged in research and contributing to the advancement of knowledge in her domain. She is presenting a paper in national and international conference and publishing in reputed journals. Showcasing her dedications to the excellence, academic excellence, his innovations in organizing the workshops and faculty development program. Further underscore, he has committed to the professional growth and the knowledge discriminations. Dr. Madhumita ma'am has enough multifaceted contributions, has made her included part of variant academic committee at the SRM University. Welcome you, ma'am.
Thank you, ma'am. Yes, good afternoon, everyone. I think I'm audible to everyone.
Yes,
Yes,
ma'am.
ma'am.
Okay. So already we had some introduction sessions yesterday by a resource person regarding deep learning. So today I'm just going to expand the same session. So how this deep learning, we are using it in the IoT. So I'm just going to say what are some of the techniques we are going to use and what are the challenges present in using the deep learning methods in IoT and some real world applications which are related to IoT and it applies deep learning. So these are the topics I'm going to describe about today. First of all, I'm very happy to handle the session in the College Vinayaka Mission because it's from my native place. So it is good to start a session with you all faculties. So shall we go into the slide? Is my slide visible?
Yes, ma'am.
Okay. So we are just going to roughly know what is deep learning. So as you all know, deep learning is nothing but an enhancement what you have made from the AI or machine learning. So you're just going to extract some more features and you're just going to apply some mathematical algorithm to the both machine learning with some AI techniques. So that this is nothing but an intersection of the data between AI and machine learning. So how this can be used for Internet of Things. So this is a somewhat crispy layer because generally we use always the deep learning techniques for healthcare and medical issues and some image processings. But using deep learning for IoT is one of the new techniques and it also has many challenges. Okay, first before using it for the Internet of Things, we have to know what is Internet of Things. Internet of Things is nothing but it has a high amount of technologies which are interconnected with intelligent devices. So we have so many intelligent devices interconnected and we have many communications, many data transfers between them. So so that is why we always mention that we have many challenges using IoT and applying deep learning into this IoT. So these devices generally have a surge of data where there are we have to process them very efficiently and we have to do the analysis in the meaningful manner and the final decision making has to be taken care. So when all these things are taken care while applying this data into the IoT devices, after that only we can apply this deep learning methodology. Generally we have deep learning is nothing but it is a subset of machine learning. As I said, it is an intersection of machine learning. Here they are saying that it is a subset of machine learning and we have many mathematical algorithms or functions which play a vital role in applying deep learning. So the general deep learning techniques are convolutional neural network, recurrent neural network, deep belief networks, and other significant networks you have used in small projects. But how we are going to apply it into this IoT diverse data, that matters a lot. So these functions can be extracted from non-redundant informations or patterns from the data. So it can also create a relationship between all the input data and output data what you apply into your IoT devices and to your mathematical model. So generally, uh, we need a training process. That is, once you take the data from these IoT devices, the next step what you will do always is to train the taken data. So the data can be the information from the devices or from the internet sources which is equipped to your machines, and then apply this mathematical model. So this is generally the process of the deep learning method. So as I said, we can classify this programming into the classic programming and machine learning. Okay, so since it is an intersection of machine learning, so we'll just add some classic programming techniques, that is nothing but your mathematical model, and some machine learning models incorporating both. You can call it as deep learning models. So here you can see this interaction. Yes, sorry for the interruption. Can you hear me?
Yes, ma'am, you are audible.
Yeah, yeah. Okay, thank you. So, as I said, deep learning is the intersection of machine learning. So, this is a diagrammatical representation where it incorporates both the machine learning and artificial intelligence. So, now when we take the deep learning models, it actually has many advantages. Okay, and it also can be used for the multiple benefits, like not only uh, using for the technological landscape, but it is also solves the complexity, uh, like it can solve only the specific demands or something like that. So main advantages is that it can extract a huge amount of features. That is the use of the deep learning models. So it doesn't has any particular member, and it can extract features even from the raw data, that is not the plain data, which are equipped from the sensor, because these deep learning methods we are applying for the IoT devices. Most of our IoT devices work through the chips and sensors. So usually our data used to be very raw or sensor equipped data. So for extracting features from this raw sensor data, it is very easy when you apply this deep learning methods. So this can also help in making the unstructured data a structured one, removes the noise, and sometimes there may be interconnected data between two systems of the IoT devices. So all these difficulties can be overcome by this advanced deep learning methods. That is why we started using deep learning algorithms when compared to this machine learning algorithms. So that is the difference. And next is uh, what what can be the applications actually. The applications can be sometimes real time applications or time sensitive applications. Okay, so this deep learning algorithms can be applied for both, both or real-time applications or real-time streaming of data or IoT applications which has some data analysis, like when you are using it for the weather forecasting or something like that. So all these real-time applications it can be implemented, and it can also be implemented in timing analysis. Okay, So timing analysis is nothing but sometimes you use it for the natural language processing where you need some memory to restore what was the previous input. Based on the previous input, you used to compare with the next coming input with the time difference. So for that kind of applications also, it is used. So deep learning was first in the books, actually in the books and in the theory portion, we had it around 1980, but only after 2005 or 6 we started using in our world. That too not in our country. We used to use in UK, China, in such way. But only after 2015 it became a very hot topic because every application finally they have a touch with this deep learning algorithms. So now even we can see all our final year projects, students are using this only this deep learning and machine learning and updating the uh, all the applications with all the applications or the data which they have. Very importantly, even the medical field started using this deep learning techniques. And further, nowadays, for the smart cities, we are updating our country even for this traffic signals, bridges, etc. So the to make our city smart, we are using this methods. And finally, even for the agriculture, so we know agriculture is a backbone. So we are even helping even the uneducated to know the parameters uh, or how to handle this whole agriculture in a smart way. So since we are making our uh, India's real-time applications very well from 2015 actually. I'm just talking from the literature surveys I have studied because we started applying it only after 2015. Even these algorithms were developed in 1980s. So um, and I appreciate the people who started applying it in the IoT devices, and they and the one more hot cake is they have applied even in the cyber security for this data analysis. Mainly, deep learning is done with the help of this GPU systems. Okay, because we always we will be dealing with a huge amount of data set. We cannot run it with one CPUs. So generally, we take the help of GPU systems. Uh, and for the small projects in nowadays, our students are using Google Colabs also, but that doesn't work for our projects when you are taking some real-time data set or some huge data set. You will obviously be requiring a GPS systems. So we have, as I said, this deep networking has some deep intelligence systems. So we have this neurons, as I said. So all the neural networks are become acts as an example for this deep learning methods. So these neurons have some intelligence, means the data is added with an intelligence, and we are going to do summation of that, and we are going to make add one activation function so that you have to filter what you need as the output. So that is the activation function. So this activation function changes for all the features what you are applying. So this is generally how the neuron looks like this. Yeah, you'll always be studying about the different neural networks like convolutional neural network, uh, many neural networks, but general neuron structure looks like that. You will have the data from x to xn. So you will add some uh, features to that. Okay, like you can use data augmentation techniques, anything. So these added features will enhance your data set. After that, you are going to do summation, or you have to do some training portion and extract what you want as the output. So this training and your data augmentation plays a main role to make a perfect neuron or a perfect data set what is what you are having. So this is common for all the department wherever you are using this deep learning methods. So this why this neuron is very important, because it copies just like our human brain, like how our human brain is intelligent, and it is how intelligent it is working, and how intelligent the memory is retaining, and how you are applying to the next action. So the same thing the neuron is uh, performing, like how your human brain neuron performs. So that is why we always call it as a neural network. So another perspective is that you have to understand how the human brain's neuron works. Then only you can apply the same concept to this your neuron. Okay, so then you can build it to a mathematical model. You can add yourself some features, and you can upgrade your data set as a very new data set, and you can upload it into the GitHub. So uh, this will act as a good research scope for you, and it can also help the others to take your mathematical model and work on it. When they apply your mathematical model, and when they refer your name in their paper or the model, so you will be getting benefited, and your co-partner also will be getting benefited. This is the use of making a new mathematical model. But when you are making the new mathematical model, you have to be like very sensitive, like you cannot publish any wrong data or something like that. Whatever percentage of increment you get, you have to when you're posting in the GitHub, you have to be very genuine about that. Then only the other co-partners can use your mathematical model. So when you learn this neuron structure and apply it to your data set, so this can be very helpful for your research scope. So the next thing is deep learning is very essential to do everything that the machine learning does, but it is not like vice versa. Like machine learning cannot do everything, but it needs the help of deep learning. Same thing, deep learning incorporates few methods of machine learning, but not everything about the machine learning. So machine learning is useful when the data set is small and well accurate, and data should be very pre-processed. That's then only we can make a proper training of that particular data set. So it also requires some human intervention, and when the data set is growing large, your complexity also grows large. So this machine learning algorithms always extract the information of how complex the data is, and how fit it is to your particular problem, and how fit you can make your mathematical model. How fit you can make your mathematical model. So these all the things you have to know very well before using your deep learning algorithm to the system. So the choosing of the algorithm must be very genuine. Okay. Usually, so the next alternative to deep learning is generally the machine learning, because it works in the same way, and it is also termed as a shallow learning. It is very effective for the smaller data sets. So, on the other hand, it is extremely powerful when the data set is large. It can also learn a complex pattern from the data and can draw an accurate conclusion on it. So it has both the unstructured data and structured data. So we have to make this text as corpus, and arrange it to according to the social media activity we do it. So it can also generate a new data samples and find an anomalies that the machine learning algorithms and the human eye can miss. Okay, so this is how a few difference I can show diagrammatically between the machine learning and deep learning. So here you can see that deep learning can make the feature extraction and classification in one module. but machine learning, whereas only after extracting the features, you can give it as an input. Later, you can classify it according to your need, and then you get the output. So, generally, the neuron structure of the deep learning is simple and it is smart when compared to the neuron structures you design in this machine learning part. Okay, so these are the different neural networks and how they behave on the amount of data. So this deep neural networks is a random growth. You can see its performance. Even your data set is increasing, the performance is also increasing. So from the many literatures, we can find that the deep neural networks works well, but always what we needed is a large training data. So you need a very huge data so that it gives the accuracy to that level. So the data set level and the accuracy level remains gradually increasing in your deep neural network. So obviously you need some GPU systems to work on it, because you will be having a large trained data with you, and your mathematical advancement should also be the updated algorithm. um, so now we know that neural networks, that is deep neural networks, play the huge performance. So I'm just going to discuss some of the deep neural networks. That is, just let's first see about this convolutional neural network. So they are applied for both images and video analysis actually. So this convolutional neural network excel in detecting the spatial patterns through the convolutional layer, and it is also invaluable for the task like image classification and object detection generally. So as I said, this convolutional neural network can be used for both the images and videos, and mainly it is used for image classification and object detection. Convolutional neural networks also has very good advantage, like it has a huge feature extraction process. So here the more number of features are extracted, whereas convolutional network has many layers, and each layer can apply some filters or kernels into the input data, and can effectively uh, recreate the data and show the different features, its textures, edges, shapes, and some visual clues if you need, if you're using some video data. So all these things can be done by convolutional neural network. So convolutional neural network is very famous among all these neural networks. Next comes the recurrent neural networks. So this is slightly different from this convolutional neural networks. This recurrent neural network is also called as is used generally for sequential data. That is, as I said, like it is used for the natural language processing and time series analysis, where sometimes the past inputs has to be remembered and temporarily stored to analyze the future inputs, etc. So one more thing we have as long short top memory LSTM. Uh, we have studied in our AI subject, I guess. Like this LSTM networks is similar to this RNN, but we use this for the gradient problem, and it is well suited for the long-term memory retention. Here, um, it requires a long memory backup. That time we use like LSTM. Its working is somewhat similar to this RNN. So one more new thing is it is gated recurrent unit networks. So this gated recurrent unit networks is just like this LSTM, where you have the it has a very simplified architecture, but it is computationally it is very efficient. And compared to this LSTM, this GRU is computationally efficient. Finally, we have the fully connected neural networks. This is nothing but here the visibility is more. It has a multi-layer perceptrons. Uh, and they are versatile. They can be used for the various tasks, including regression and classification purposes. So, this fully connected layers, uh, it can also serve as the final layer in the deep neural networks. So, it plays the central role in synthesizing the output from preceding layers, and it also acts as a comprehensive prediction. So this is generally about how this neural networks and types of neural networks working. So how the features are extracted and classified. So this extraction, I will explain more how the input is taken, how you're performing convolution, and how you are doing pooling, and finally how you're using this fully connected network and solving the output from that. So this is the general classification what deep learning does. So I'm just going to explain what all the things there. So from on the downside, the deep learn is computationally expensive compared to the machine learning, which is also means that it requires a lot of time to process. Deep learning and machine learning are both capable of different learning items like supervised learning, that is labeled data, and unsupervised learning, that is unlabeled data. And it also uses it for the reinforcement learning. And it is also useful for usually determining the size and complexity of the data. So this machine learning requires a data processing which involves human intervention. So the neural network is the deep learning capable of extracting the features, hence no human intervention is required. So this deep learning can process the unstructured data. Deep learning is usually based on the representing learning, finding and extracting the vital information or patterns that represents the entire data set. So this deep learning is computational, expensive, and time consuming. This deep neural networks has multiple layers, as I said. So here, this artificial neurons are interconnected, and the nodes are stacked together. Each of these nodes have simple mathematical function, usually a linear function that performs the extraction or mapping of the information. So, as I discussed, what are all the layers that lies in the deep learning networks? We have a input layer. Then we perform the convolution and polling. Then how we are enhancing this predictions using the comprehensive prediction using fully connected layers. Finally, we draw the output layer from the neurons. So this is how there are different layers of the deep neural network works. So you can see this. So this hidden layer 1 and hidden layer 2 are nothing but they perform some poolings of the feature extraction. So feature extraction is nothing but there is some critical component that lies in this process where the network automatically identifies some key pattern or relevant information from this raw data. So these key features are characterized again further into how the texture or shapes of the images you want, and it enables the network to comprehend the underlying structure within the data. So this hierarchical feature extraction empowers this deep learning model. So you can transform even or complex or unstructured data to some meaningful representation. And you can also facilitate your data with some accurate prediction and insights. So the integration of deep learning into this Internet of Things presents a promising avenue for enhancing your IoT capabilities. So always you need to survey before you're applying this deep learning techniques because you're applying it for IoT context. So you have to include the CNNs, RNNs to provide some understanding, and you have to understand both the strengths and weakness. Secondly, understanding can operate all the challenges that apply crucial to your data, and doing more research on that particular topic can improve the performance of this deep learning in various applications. So whenever you're using these IoT devices in convergence to this healthcare, human recognition, and surveillance application, so your performance of the research grows high. So this is what when it goes to IoT. So generally, when I talk about some research gaps, what a deep learning into an IoT can have is you can have a broader thinking or broader adoption of some real world scenario. So you can take some real world case studies and work into it. So like helping out NGOs and their services. This is one of the case study I took from uh, 2023 paper. So you can just take a real-time case study and then apply this uh, broad and real-world scenarios to the IoT. So this will make your research look good and effective. Mm, so these are the neural networks I just discussed. That is artificial neural network, convolutional neural network, RNN. That is recurrent neural network, and generative adversarial networks. CNN is primarily used for the computer vision or image processing. So I said we can use it for both the image and video processing. Generally, it detects the object. So now they are performing this convolutional neural network in both underwater and out of space. Okay, so to make more number of devices interact with your atmosphere and collect the real-time data. So this CNN plays a huge role for both 2D and 3D images and videos. So this is the whole scale how the feature extraction and classification works. So this is the updated pooling version or convolutional version how the CNN looks like. That it has more than 16 layers. Previously, they used to work with 8 layers. Now, the convolutional pooling has increased it more than 16 layers so that uh, we have a very big comprehension perception from that. So next is that, as I said, the recurrent neural network is used for the sequential data and it helps in the natural language processing. So these are the layers for that. We have input layer, hidden layer, and the output layer. So this architecture looks simple because here the memory power plays a major role. Here all the inputs has to be saved for analyzing the next forthcoming outputs. So this generative adversarial network is generally used for unsupervised learning. This type of network is essential to learn the structure of data, and also for new examples like for original data sets. Like you can take the images of your own or downloaded images and you can check whether this is real or fake. This is one of the case study for um, generative neural networks. So these, yes, shall I continue? Did you understand what is CNN RNN? Shall I continue or shall we stop and discuss any real-time case study you're working with? Because if I keep on talking on the theoretical issues, uh, all of us will get bored. So if anyone is interested to tell about their neural network, what you are using in your research, we can discuss your case study if you need. Is anyone interested? Or you just want me to continue with the theory? Yeah. Lekha Kavi ma'am is asking to discuss any case study. Okay, ma'am. Lekha Kavi ma'am, are you online? Raji Amo ma'am also raised hand for the query. Ma'am, are you online? Audible? Yes, ma'am. Ma'am, it will be very interesting that if you share what you're working with so that I can discuss with you. Yes, Raji ma'am, you can speak. Yes, yes, many of the faculties has raised hands for discussing about their case study. Okay, uh, but I'm not able to hear anyone's voice out. Just unmute yourself and discuss your case study. So you are all muted yourself, or you're muted for the whole session.
No, ourselves only.
Okay, sir. Kannan, sir. Sir, please tell me what you're working with neural network, sir.
Right now, I'm not involved in anything as
You're not
such.
okay. You're not involved. Okay, so I'll tell about my experience, sir. I have done one project in NPOL, that is one DRDO project in NIT Trichy. So what was that project was we have to do the uh, shark or underwater identifications when you travel underwater. So you have to identify this, classify the submarines and the shark with the help of its sound. So my data set was sound. So I used convolutional neural networks to classify the sound. Uh, Sound. I also did some data augmentation techniques to enhance the data set. Later on, I just classified whether it is the sound of the ship or submarines, or it is from the shark. So that project I did in 2021 to 2023, 2 years. So after that, still I do some underwater voice detection. So we don't have networks in underwater, so we totally depend on some acoustic signals. So I use some communication and acoustic signals incorporated along with this mathematical model, uh, convolutional network, and classify these audio sounds. So this is my current research. So I'm just going to travel on with this for still 2 years. So, just like this case study, if any one of you is working with, you can discuss with me. You can unmute and stop me and discuss with me. So, if I have some idea, I can give you. And if you uh, faculties having some idea about my project, also you can suggest me, so that when I do my next research article or next research, I will apply it to that. So, our discussion will be live, like simply I am talking the side as theory is not useful, but when you guys talk up with your problems, we can share the queries, and I can give you ideas, and you guys also can give some ideas to me. So that will be the make the session live. Is it okay?
Sure, ma'am.
Sure, sure. But so far, if anyone wants to tell your idea, you can tell, or else I'll continue with the PPT.
Ma'am, if you permit me, I would like to take on another minute only.
Okay.
Here, one project what I'm considering right now is there are autistic people. For them, the autism jacket is to be developed. The product is autism jacket.
Okay.
That is essentially they'll will sense the body essentials.
Okay.
There could be
Okay.
11, 12 inputs,
Okay, sir.
and based on it is going to develop a hugging equivalent kind of it's a
Okay.
jacket around their torso. So whenever they get into that tantrum, it will initiate some energy so that it will give the tightness around the torso, so they feel somebody hugged.
Okay.
So
Okay, sir.
and it is simple to say, but it is a real time dynamics. So basically, their mood set and physics, ambience, and henceforth so many things. So suppose if
Okay.
it is going to work 100%, the autism students can attend the university education itself. That is the bottom
Okay.
line of it, with which we are trying to work on that. Different
Okay.
techniques already we tried on, but deep learning we thought of employing. So that I am
Okay.
here for your attention.
Okay, very good, sir. Very good, sir. Karan. This is very nice. But actually, I have heard that already for the autism students, they have hand bands actually. So this hand bands used to some measure the parameters of this artificial autism students and tell us with the help of sensor. So we used to do it with the hand bands. Have you heard about that, sir?
No, handbag I haven't. I was told
Okay.
handband one thing, but not sufficient number of body essential being
Ah,
the
yeah,
input
yeah,
being
yeah,
generated.
yeah.
That's what
So
they
number
told.
of parameters
Bag,
was
this is the
less
first
when
thing I
you use.
mentioned. Yeah.
Yes, sir. Before in 2020s, they used to make that hand bands, and uh, and also for the memory loss patients, also they used your techniques, or like using this jackets or hand bands or this techniques where they are using now. So this is also when one of the latest technique. I think I appreciate Dr. Kanan sir who do this, who just gave his idea upon the deep learning. Anyone else is going to share your views? Okay, thank you. I think I can move on the next topic. So now I'm going to just talk about the data availability. So generally there are a lot of data. So how it should be?
Hello, madam.
Yes, 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 sir.
Good afternoon, Andy.
Good afternoon, sir.
This is Dr. Prasad Dharmasi from Holy Mary Institute of Technology and Science, Hyderabad.
Yes, sir. Yes, sir. Very good, sir. You're Telugu.
Yeah, Telugu, madam,
Oh,
Hyderabad.
okay, okay, sir. My sister is also from
Holy
Hyderabad.
Mary, Holy Mary Institute of Technology and Science, Hyderabad,
Okay, okay.
CSE department, Computer Science and Engineering department.
Very good, sir. Very good, sir. So what is
Are
your
you
idea,
using
sir?
any? My idea is not an idea currently, but what type of algorithms are using in your topic? But I couldn't understand regarding your explanation. Are you using any type of algorithms?
Yes, sir. I'm using algorithm. You need the mathematical model, or you need the deep learning technique. What I use? Deep learning technique is nothing but I use convolutional network, sir. Okay, in
Okay.
that I am using one mathematical model for compression sensing, sir, because here the data is full of audio, no. So we cannot transfer the underwater
Okay, madam.
network with the help of a real-time data. So I am just using one compression sensing algorithm, sir, mathematical model.
In that way, we are using a mathematical model.
Yeah, yeah. I'm just adding one mathematical model to convolutional network. Similar way, you can add your one mathematical model to this deep learning technique to make it more efficient. So Raji ma'am has asked, how will you get the data set, ma'am? Yes, I have downloaded from the net, but that was not enough for a DRDO project. So I like you can go to some government websites of NPOL, like Bay of Bengal or Indian Oceans. You can submit your project letter. You can get some real-time underwater data sets from them, ma'am, actually, if you are having permission. So if you don't have permission or you just want to try some research articles, you can download from the Kaggle that is available on Google. Everyone can download it, and you can just initially work on that particular data set.
Okay, madam. I understood, madam.
Okay, okay. Thank you. Any other queries, ma'am? Shall I move to the next one? Okay. I think
Yeah,
now
sure,
the
madam.
yeah, I think now the uh, every participants are alive and the session is going live. So now I'll just have some more theoretical discussion about how the data is available. So generally, the data availability is very important when you apply this deep learning model. So it requires a lot of data to learn its representation, structure, distribution, and pattern of this data. So you always needed to have a note how it represents and what is, whether it is a structured data or unstructured data. So what is this pattern of data? Whether you have to improve this pattern of data with some more data augmentation and feature extraction. So always you have to take care of all these things before you apply the deep learning model. So this varies from data to data. So every data is not similar, right? Each data has its own challenges. So you have to model it you have to generalize it first. Then you have to allow it for the training and enhance your data set. So this is about the data availability. So obviously, when you have more amount of data, you have more complexity in this model. Like the main complexity is how you design a deep learning model without any error. So this is the first thing. Next, you have to make the model very simple. So it should not be very underfit also, and it is, your model has to extract all the information from this training set. And but when you use some complex model, sometimes it will be overfit for your data set. In that case, you can use the simple model. But when you generally require a very complex model to give the high performance, you have to check all the data performance, and you have to generalize this data set. Deep learning models will perform well for all the complexity type of data sets. So here you can apply it for all the complex data sets. So this now we are going to discuss about how this global generalization works. What happens actually to the data set if there is no generalization portions? That is, when you are taking some simple networks, so it used to have some n number of parameters. So your model has to update every time when you apply a new data set or when you use a new model. There will be always some generalization errors also whenever you are doing this testings. So how to solve this generalization, zero generalization error, or is this, you have to make um, the you have to increase the exploration and analysis. So how I can reduce this generalization error from the data set is, you have to increase the analysis or examinations of the data set. When that is, you have to concentrate on the feature extraction and classification. That can reduce this generalization error. So one more thing we have is multitasking. So deep neural networks are always not always, sometimes it's incapable of this multitasking, because here in this layer we generally have both the feature extraction and classification as one portion. So sometimes it is always incapable of this multitasking. So in order to make that, you have to make the training process more. So the training period or the training algorithms must be strong to make this data set handle this multitasking. So in many applications, we require some intelligence that can come beyond this generalization of deep learning, and can be applied to this large data set without any complex. So that general intelligence has to be added to this current deep learning technique. So as I said, you cannot work so complex data with CPUs. You always need some GPU systems. I hope in every of our institutions we have some GPU systems, labs, and GPU systems at your every lab. Not at every lab. At least we have in few labs where you can try it in the college time. So this purely depends on this graphic processing units and tensor processing units. So what is the difference is the timing. So TPU is required for only the shorter timing. So this processing time saves time. Generally, before in 2015 or 2014, research scholars what they have to do when they want to train some data or train some model, they upload all the data sets into the system and they wait for 2 3 days. They allow the CPU to work on this data set for 2 3 days, and they used to stay in the labs to see the model how the model is going to work. So now we don't have that core competency work because we have GPU systems everywhere, so we can just get the outputs in minutes. So it generally saves the time and energy. So these are the things it can do. So my portion of research is sound addition. Okay, so generally they do many things. Okay, where who the people who work in image processing do the pixel restoration. Okay, and for self-driven cars, they are using the deep learning techniques, automatic handwriting generation. So we have now online signatures, online written assignments. Now students are doing this automatic handwrite generations are used, like they can write the assignments online, and colorization of black and white images. Okay, so the old photographs, black and white, which are taken in 1940s, are now again we can make it color. We can do this colorization. So for that also, we are using this deep learning models. Even in the healthcare detection of this growth, if there is delay in the growth of the womb, for all these things, we are using this deep learning things. And news aggregation. So this is also one of the hot topic because uh, whatever news we have now, even the population is high, we have a huge amount of news. So this news aggregation helps us to make it crispy and shorter. So this is also one of the hot cake in the research space. And one more thing is automatic mission translation. So we use it in the many automatic missions. So these are where we apply this deep learning techniques. I hope the faculties who are attending this FDP are working on any of this classifications and you're applying your deep learning models. So this generally how the deep learning is very successful with the help of what neural network you use, what architecture you use. So based on these two modules only, your how your deep learning is successful. So now we are going to talk about the perception. So I already I told how the neuron looks like, right? So how the summation function is you added and your activation function is added. So the activation function is according to your problem statement. So how you take this problem statements equation you're taking, you can take it from your survey paper and you can apply the activation function based on that. So previously I have told about how the neuron structure looks. So I'll share this my slides with you. So this is how my I have shared my neuron model equation. So how I apply for the RAM function or the sigmoid function or Gaussian function. Since I work on the communication systems, I used this as my activation function. So these are my equation which applied for my research work. So here you can substitute it according to your case study or your research work. So generally, all the neural networks use this multi-layer feed forward. So this multi-layer feed forward neural networks has this following hidden layers. So I'm just going to explain about this feed forward neural networks. Yes, thank you for giving me 1 minute. We will resume. So this FNN is more general network architecture where there are hidden layers between both the input and output layers. So these hidden nodes do not directly receive the inputs or send the outputs. So they have some processing unit in this. So this processing, as I said, it incorporates both the feature extraction and training process. So there are also Cephalin also feed forward neural networks generally overcomes all these limitations in the single layers, and it is applied for the all linear tasks. So this is about how the random numbers, initializing all weights to the random numbers. Weights are nothing but your classified inputs. So how you are making some back propagation. So this is also from my research. Next, in this neural networks, these are the things you have to consider, like how the data is represented. First, I said we have to always think about the data set. So what is your network topology? What is your network systems? So what are all the devices incorporated in that? So what data you are uh, equipping from each devices. So always when you are applying this deep learning networks to this IoT, you must always know about your network topologies and network parameters. So it plays an important role. Next is the training session. So this training session is very important because it it tells their performance and how your output is validated. So I have given some case studies and the literature survey where it is taken from my research how you use this linear function and sigmoid functions into this hidden layers, and how we are overcoming the underfit and overfit of the data set. What happens if your data set is underfit, and what is the performance if the data set is underfit, and sometimes when you have overfit data or overtrained data, so how your performance is there, so how we are overcoming this generalization error. So all these things I have just shown in the graphical way. So the general motivation is that, like, how you can use this accuracy or how you can use the parameters for your IoT application. So generally, what is the research space or research scope for this IoT, Internet of Things application? So Internet of Things is not where I have applied the deep learning, But generally, when they gave me a topic to talk about this IoT, that is Internet of Things applications, I randomly checked where they have used this deep learning method is. One is they have used it mainly in the anomaly detection. So, this deep learning methods, they are using it in the anomaly detection first of all. Next, they are using in some human activity recognitions. So, how this human activity is recognized with the sensor devices. So, mostly the second portion they are using for the human activity detection. Any other IoT applications you are working? And finally, it's a healthcare because all the IoT devices works with the healthcare mainly. So everyone knows about this. And finally, we discussed about the healthcare and some surveillance applications like we use for now the Amazon recognitions and few real-time applications I will share regarding this surveillance application. So, what is the latest one? So, first one is when coming to the anomaly detection. So, how this deep learning can integrate with this anomaly detection, how it can apply this IoT realm. So, this transformative information, I'm just going to discuss with you. So generally in IoT, we use some data analysis and identification only that. Now, when I apply this deep learning techniques, so uh, we use some manual feature extraction, some rule-based systems, and other things to make this anomaly detection perfect. So this making this anomaly detection, it makes this IoT application very diverse, and we can also do some real time monitoring. Always there will be someone to monitor from any place. So it is including some real time monitoring system, and it is also helps in predictive maintenance and control systems also. Excuse me. So any one of you working in the anomaly detection? So the anomaly detection with IoT systems has some notable challenges like it has some open data sets, and we can also compare various models so that there is very direct comparisons with the adult various models, and some researchers also have a feel that they have they cannot have their own private data sets on their own, so they always do this comprehensive analysis based on the existing data set, and there is no standard evaluations on that. All these can be cumulated together and can be solved using the high metric scores and comparative analysis. So how to make this comparative analysis use is that we can use many models like artificial neural networks or the convolutional neural networks to this. So this anomaly detection can be used with the help of both convolutional neural network and artificial neural networks. So uh, we also know about this F1 scores. So that is nothing but your performance of your approaches. So there are many deep learning approaches like decision tree. So we can call it as a DT and a random forest RF. So these classifiers exhibit the highest F1 score. scores when compared to the others. That is about 0.99. So that can be considered as the maximum. And we can also have this machine learning classifiers like support vector mission, logistic regressions. This can also have the F scores of about 0.98. Uh, in contrast, we can use a different methodology that can be also used as a segmentation based self-taught convolutional networks. That is a new one actually. So SSTCVN, that is nothing but the segmentation based self-taught convolutional neural networks. So it has the less F score, that is about 0.96, but this can be applied to all the complex neural networks, and it is also sometimes overfit for the simple data sets. But when you really have a complex data set and huge data set to be converted to a simple pattern output, you can use this segmentation based self-taught convolutional neural network. So overcoming this of anomaly detection, the next one is human activity recognition system. Here in this human activity detection, like you can use it for the mini IoT application, like real-time monitoring. So here you have a number of layers for monitoring this convolutional and polling. So you convert this input into the flattened output. So this number of layers you can use LSTM for that. So this is I already told LSTM has some memory management system where you can store the memory of the previous inputs. So for the real-time monitoring, you can just add some LSTM layers to your architecture. So one of the standard model is deep convolutional LSTM architecture. So this is one of the new LSTM architecture where you use deep convolutional neurons along with this LSTM architecture. So it makes your image, it can upgrade your image recognition very well so that your inputs and outputs doesn't has any errors. So it is a hybrid feature based method, and its performance is 93% at the time of 2023, but I don't know whether they have solved it after that currently. So finally in the LSTM, when they use this synergy between the deep learning methods and IoT applications, so here they are making the architecture more efficient. So the output what you get is supposed to be very accurate, and the um, uh, real-time data analysis is also good. So as I said, this deep convolutional LSM model is good, and it can be used for your research space if it is suited. So this is another one architecture, how your neural network looks like that, how this image classification is done, and what is the performance rate from 2010 to this image classification. So these are the different layers of the convolutional neural network. Here you can change according to the architecture. You can increase the number of convolutional layers and you can increase the number of polling layers according to your problem statement, whether it is an image or video. So these are some of the example how the images are converted into the structured output. So some of the training inputs, we have some sample batch of data, then you can forward it to the network to get some prediction. So if we have some errors, we have backproc and then update your weights. That is nothing but your update your inputs. So this is the dense net data set. So this is also one of the model. So what is the huge challenge of using this uh, deep neural networks is sometimes it may be overfitting and vanishing gradient. So you have to concentrate both on the acceleration and hyperparameter tuning. So these are some of the complexities that lies between the different nets. So I have just compared the AlexNet, Google Net, ResNet. So all this performers. So this is the difference. So now let us discuss about the real-time applications, what we are doing with the IoT technique. So here you can say that they are doing some pixel restoration and also with the sound. But generally, uh, we use this deep learning applications to detect something. And as I discussed earlier, like anomaly detection and also mainly like healthcare. The most important application is healthcare actually, because all the IoT applications that rely on this healthcare due to the accuracy for the diagnosis, enable the personalized treatment, monitoring the patients. So monitoring the patients, it's there at time to time, and we have to also provide some resource constraint to them with the help of these IoT devices. Here are some of the most commonly used some deep learning models for the healthcare is CNN only. So that is not only used for the medical diagnosis, it is used for personal health care and disease prediction, sometimes also to the behavior recognition. So these applications are also useful to improve the patient's uh, quantitative metrics. So these deep learning models uh, is very sensitive and they give the performance about 97.5 percentage right now in healthcare than previous. So one of you has put a message like what is the computer vision towards this deep learning method. The computer vision is nothing but you can suppose if you are taking an image processing or if you are taking medicine, so whatever you are taking, you are just diagnosing diagnosing it with a model, um, either a mathematical model or a deep learning algorithm in a simple code. So when you're doing this, you are getting an updated prediction of the output. So this is the computer vision. As a computer science faculty, we can able to diagnose this data in the better way and give the accuracy with a simple algorithm or a simple code. So all the accuracies as of now lies above the 95 percentage. So this is one of the great achievement from our side, I think. So, and there are other healthcare applications. Um, even you can monitor the patients from home, and so you can take the data types uh, like audio, uh, like very depth data set, or you can use the methods like TSN, FCN, DBN, and GAN, as I discussed in the previous thing. So this accuracy is ranges from 95 to 97.4. So they have what all the methods I have told. They have their own architectures and they have their own layers of neural networks. So these all things varies from method to method, and the architecture also varies from the method to method. So um, I can share you about all the methods and its performance range. If you want, I just have a club of the hybrid featured based methods which are having different accuracy and what and their architectures in as a whole in one literature. If you want, I can share along with the PPT that particular survey paper. So it will be helpful to take a reference which model is very accurate to your statement. Uh, Generally, we always use this IoT to both the healthcare and home related issues. Why we use some home related smart techniques? Why we need our home to be smart is we always use many appliances in our home. Um, like we need it to be always smart. Even when we use a fan in our home, we just you we just need to be updated in everything. We feel like we need the updation always. Now we use some remote fans, sensor fans. So that will do part of our work. So we always transform into a smarter one. So deep learning can be also used for the home related techniques. So here DNN model helps to improve the accuracy and cost for the monitoring. So other there are also some low accuracy models when compared to the deep learning models. So I will just show the list of the models. When you're using this deep learning models to your healthcare, um, there are many common case studies which we are doing it right now. We are just testing some patients with multiple chronic conditions, whether the patient is having this multiple chronic issues. Okay, so its main focus is to improve the home-based healthcare. And next one is personal health assistant. So we need not go for the checkup each time. So we always take some parameters or some sensor data from ourselves and make link it with the smartphone and just analyze the health. So this personal health assistant is another one scope people are working with. So its main focus is to establish a link between the smartphone and the sensor data. And here also they use the deep learning methods. And the next one is smart dental health. So here there are some smart hardwares or mobile terminals to monitor this dental health. So um, here it has a challenge like it has some incomplete coverage of the larger teeth. Okay, so that time we have some challenges in this application. So the next is patient monitoring system. So if you want to monitor some old people of our family, we can do the patient monitoring system from the home. So here also they propose the deep neural network to analyze the sensor array data for the patient condition and monitoring. Uh, Next is fall detection. This is very classic and old. So this is used to detect whether the particular object has fallen or not. So here also they use it some deep learning models. So next is the multi-act physical monitoring system, and finally the nutrition monitoring, whether the food we take is nutritious daily or not. When you create a table and connect it with a smartphone, so you can just sense that you have taken the nutritious food today or not. So this is also nutrition monitoring. There is one of the smart healthcare application that is done with the deep learning models. So other than this healthcare, we also have some IoT surveillance applications. So this IoT surveillance applications is mainly used for the advancement of the security and its efficiency. So in the recent years, generally we generally do the real-time monitoring, data analysis, predictive insights, but the surveillance applications helps to address many hurdles, like if one particular if the data is disconnected, usually we used to take the data from n number of equivalent data. Suppose if one particular devices is not working, it used to make a comprehensive data from the other data. So so the deep learning is helpful for that. So some of the surveillance applications are nothing but facial recognition. So whenever you enter a particular public space, this face recognition plays a very role. We also do it for the object detection and also for the deep learning systems, and for the security mainly, like intrusion detection in IoT. So security also plays a main role. So these are some of the surveillance application. There are many very uh, various case studies that is uh, usually implemented in this IoT and machine learning technique in the smart cities. So it also provides some urban services, and it also helps some quality of living for our citizens. So generally, the deep learning algorithms have all the general benefits to upgrade the state of living of the humans. So these are the applications. I previously discussed about the colorization of black and white images. Like you can take some photos as the inputs. You can colorize the images that represents the semantic shades and tones of the input is known as the image colorization. So it is also done traditionally. This technique is carried out by hand and required human labor. However, today deep learning technology is used to color these images by applying it to the objects and their context within the photographs. Essentially, this method can also use the supervised layers of high quality convolutional neural networks to reproduce this image with the addition of colors. So this deep learning application can also add sound to the silent movies. Um, to identify these acceptable sounds for a scene, deep learning models prefer to correlate the video frames within the database of pre-recorded sounds. So this works is accomplished by training a thousands of lens that feature drumsticks striking various surfaces and produces multiple noises. So this deep learning model can utilize these videos to determine the optimal sound for the video. Later, it can set up a development to attain the best results in predicting whether the sound is artificial or not. So it also helps in pixel restoration. So in 2017, Google Brain researchers created a deep learning networks to determine whether the person's face from very low quality photos of the face. So this pixel recursion super resolution was the name given to this approach, and it considerably improves the resolution of the photographs, highlighting the essential features just enough for the identification. Next is this deep learning application also used in the sequence generation or in the hallucination of the medical field. The generation or hallucination works by creating a unique footage by seeing other video games or how they function or replicate them from the deep learning techniques like recurrent neural networks. So this deep learning hallucination can produce high resolution visuals from the low resolution photos. So this technique is also used to restore the historical data from the low resolution quality photographs to the high resolution images. So sometimes this toxicity testings and chemical structures apply this deep learning approach. Here, the deep learning approach is incredibly efficient. Specialists used to take some decades to establish the toxicity of the particular structure, but whereas the deep learning model can determine it very quickly in a hour or a day. So it also depends on the complexity of the data set. This deep learning models may represent the abstract input concepts in the hierarchical distributed way. So it allows multitasking learning and all the hazardous effects in a single compact neural network, making it highly informative. So the next is radiology and detection. So here, finally, they are used for the cancer detection also. And the model contains 6,000 parameters that might help them to estimate the weather about the patient survival. So the deep learning models are efficient and effective for the breast cancer detection. So it can be applied to any type of cancer actually. Here they have given the example for breast cancer. So it is applied for uh, blood cancer, neural cancer, stomach cancer. Okay, so nowadays students are applying it in all the projects regarding this cancer. This cancer detection of deep learning models contains 6,000 parameters and it can help to estimate the patient survival. And market prediction. So again, it is a hot topic where we all are very interested about the stock prices and this price prediction of the stocks day by day. So generally, nowadays they're using many GAN charts, which uses some deep learning approaches. Based on this, the data sets are used to train the models, and these algorithm forecast us to buy or sell, which trade we want to buy or which trade we want to sell. So this is beneficial for the short term, but not for the long term investment because the prediction keeps changing and the prediction cannot be 100%. So it is said to be it can be applied for the short term trading. So one more is digital advertising. These deep learning algorithms classify the consumers based on the prior purchase and according to their browsing behavior, they will suggest what ads, they will suggest the ads that are relevant to them. Uh, suppose you can see by yourself. Suppose if you are talking about biryani with your family, immediately when you open your phone, you get all the ads about the biryani. So this is a real-time example. That is how the digital advertising works. We can see this in action. If you search a particular product on a search engine, it will automatically show you all the relevant content alert categories of this. So this is also deep learning helps in digital advertising and fraud detection. So the deep learning offers a promising answer to the problem of fraud detection by allowing the institution to make the most use of both historical data and real-time transaction details. So comparing these two, we generally detect this fraud. Deep learning models may also be used to determine which products and marketplaces are more vulnerable to fraud and be cautious on that particular circumstances. And all the environmental attacks prediction, not only earthquake prediction. So usually we are getting nowadays more number of red alerts, Chennai, Pondicherry, Vilupuram. So all these predictions are based on deep learning applications. So not only for the rainfall, for also earthquake prediction, tsunami prediction, landslide, for all the natural attacks, we use this deep learning application for the prediction. In this earthquake prediction, the seismologists attempt to forecast the earthquake, but it is too complicated. So they incorporate the prediction cost for both the people and government. There are two ways in an earthquake. So they are talking about the earthquake here, P wave and S wave. So which travel quickly, which makes the less damage, which makes the high damage. So that can also be predicted whether the will be having the earthquake in the P wave or S wave. So it's easy to make the judgment in advance, but we need time. So using this deep learning technique, we can forecast the outcomes of each waves according to the data we have, and this may take hours to make the enough prediction and give warning to save the lives and prevent damages. So this also predicts the deep fakes to modify the digital material such as photos or videos in which the images and the videos of the person is replaced with the resemblance of another person. So this is most severe when it comes to the modern civilization. So these are some of the applications, real-time applications that deep learning techniques are using with the help of IoT devices. So I have discussed the deep learning models and the applications in the today's session. So I hope everyone are alive in the session, or you just on the session and left because it's boring with the theoretical portion. Hello, ma'am. Can I wind up the session, ma'am?
Any doubt, question, ma'am?
Yes, ma'am. If anyone is having doubts, I will clear them, ma'am.
Any doubts can go for that.
Respected faculties, I hope this session could be a little bit useful for you guys to apply this deep learning method. So if anyone is having any doubt, you can post in the message or you can unmute your phone and ask me.
Good evening.
Good evening, sir.
Ma'am, it is not about commenting or whatever it is. But the thing is, this is a topic. You mentioned if it is boring, all these things. It's never been boring. It's really, engaged way it is handled. That is for sure. Thank you so much for that.
Okay, sir.
But the concern is, today it demands little more depth and examples. And since because we got little more time, if had you come up with some more examples and little in core, maybe some codings coding samples or kind of things. That
Okay,
will
you
be little
expect
more,
some
yeah.
hands-on session, right, sir?
Yes.
Yes,
That will
yes,
be
sir.
far more useful to further utilize it.
Okay, sir.
That
Sure,
is a
sir.
request, that nothing else. It's a request.
Sure, sir. I will add some hands-on session next time, sir.
Please. Thank you so much.
Thank you,
But
sir.
it's nice and engageful way to us, ma'am.
Okay,
you.
sir. Okay, sir. Thank you, sir. So we got one query from Dr. Pari Vistar, sir. How do we build a deep learning model using the data continuously receiving from the IoT sensor? Yes, we sir, all the real your question is good one and updated one. So generally, all the real-time monitoring data, whether your IoT sensors are from the healthcare or from the agriculture or from the smart city, all the three domains, we continuously have the data set from IoT sensors and we monitor them day by day, day to day. So all these deep learning models, what I have discussed regarding this convolutional network models can be applied uh, to this daily monitoring data set. So that is not a problem that whether you have the data set which is already trained or uh, raw data set, you can access this deep learning models to even this continuous data where your storage and processing keeps changing because maybe your storage will have a problem. You have to add some cloud to that. Other than that, it's fine. You can use this. I hope you get me, sir. Anyone else have any queries? Arulmoli ma'am, can we wind up, ma'am?
Yes, ma'am. Thank you so much for your wonderful session, ma'am. It was very great. And I would like to thank all dear professors for participating and have the section very interactive. And thank you all. And tomorrow's session also will be same time, 2 p.m. to 4 p.m. Thank you, ma'am. Thank you, Madhumita.
Thank you, ma'am. Thank you.
Feedback link will be sent in a WhatsApp group. Can utilize there.